Welcome to The Explainer. Today, we're diving into a brand new way of thinking about disaster relief. It's all about getting critical supplies where they need to go, right when they need to be there. But this isn't just about being fast. It's about delivering value when everything's on the line and how a really simple shift in perspective can literally save lives.
Think about it. In any emergency, when you're talking about things like food and medicine, the biggest enemy isn't just how far away you are. The real fight is against the clock. Every single minute that ticks by, those supplies lose a little bit of their power, and in a crisis, that can be the difference between life and death.
So after a disaster hits, getting supplies into an affected area becomes this frantic race against spoilage. It is a logistical nightmare, and teams on the ground are dealing with it in the most chaotic conditions you can possibly imagine. But what if we could bring some order to that chaos? Well, that's exactly what researchers are doing right now, using some really sophisticated new tools. You see, the old way of handling logistics, it usually just focuses on finding the shortest route, or maybe the cheapest one. But when you're dealing with things that can go bad, the whole definition of the best route gets way more complicated. It's not just about showing up. It's about showing up while the stuff you brought is still actually useful. The real heart of the problem, it turns out, is how we even think about freshness. We usually see it as a simple switch, right? 1 minute something's good, the next, boom, it's spoiled. The big idea here, the real game changer, is moving away from that simple on or off view to a model that actually reflects how things degrade in the real world, gradually. Okay, so let's get into what this new model actually looks like. Instead of that one cliff where things just go bad, it breaks down the life of an item into 3 totally distinct measurable stages. It's a whole new way to look at its life cycle. To pull this off, the research uses something called a continuous piecewise function. I know, it sounds super complicated, but it's really just a fancy math term for telling a story in 3 parts. It lets the model understand that the value of an item doesn't just drop off, it changes over time in different ways. And what's so cool about this is that it basically just puts math to something we already know intuitively. First, you've got the fresh period. This is the sweet spot. Quality is high and it only goes down a little bit. Then you hit the secondary fresh period. Things are still good, still usable, but the decline starts to speed up. That clock is ticking a lot louder now. And finally, you get to the deterioration period where the item just loses its practical value, and for relief efforts, it's considered a total loss.
So once you have this smarter, more nuanced way of understanding freshness, what do you do with it? How do you actually build a system that can make the best decisions in the middle of a totally chaotic event? Well, you create a model with a very specific and maybe even surprising goal.
And here it is, straight from the research paper itself. The goal isn't just to drop off boxes. The objective is to maximize the total sum of freshness across the entire disaster zone. It's about delivering the highest possible quality of aid to the most people possible. It's a whole different ballgame. This algorithm is basically a master puzzle solver. So first, it uses a method that's a lot like what your phone's GPS uses to find the best route, and it assigns every location in need to its closest supply hub. Then, and this is the really clever part, it runs all these simulations. It calculates the potential freshness score for every single possible delivery, and then prioritizes the routes that save the most value. And finally, it spits out a clear, actionable plan. Load these trucks, send them on these routes, go. And this whole model wasn't just some theory left in a lab. Nope. They tested it using real data from a devastating flood in China's Shandong province. This was a true trial by fire. Okay, so here was the setup for the test. You've got 2 distribution centers, and they both have a pretty limited amount of supplies. Each one only has 2 vehicles, and each vehicle can only carry 6 units of stuff. Their mission? Get supplies to 8 different locations scattered all over the flood zone, and they all have different needs. It's a classic logistics puzzle, but with human lives on the line. So, faced with that massive challenge, the algorithm came up with this incredibly precise delivery plan. It decided not just which truck went where, but the exact order of the stops and how much to drop off at each one. All of it calculated to get the highest possible score for that all-important freshness. Now, this is where it gets really interesting. The model had to make some unbelievably tough choices. If you look closely, you'll see that 2 locations, V8 and V10, didn't get any supplies at all. Why? Because the algorithm figured out that trying to reach them would cause too much spoilage on other, more critical routes. It actually sacrificed some deliveries to make sure that others arrived with the highest possible quality. That is a huge shift in thinking. And the final result of this whole optimized plan? A total freshness score of 22.678. That single number represents the overall success of the entire operation. It's a way of actually measuring the total value, the combination of how much was delivered and how good it was that made it to people in need. So let's pull back and look at the big picture here. What does all of this actually mean on the ground? How does this kind of smart planning build towards a better, more effective future for disaster response? Well, the takeaway here is crystal clear. This is not just some academic exercise. When you start thinking in terms of freshness, you cut down on waste, you make the entire relief operation more efficient, and you make sure that when help finally does arrive, it's safe and effective. By giving people a clear, data-driven plan in the middle of pure chaos, this kind of intelligent logistics can directly lead to better outcomes and ultimately help save more lives. And it really makes you wonder, doesn't it? If this way of thinking can revolutionize something as complex as disaster relief, where else could we use it? This same idea, optimizing for freshness instead of just speed, could totally transform everyday things, like how our groceries are delivered, or even something as critical as transporting organs for transplants. The clock is always ticking, and it looks like we finally have a much, much better way to beat it.